All right, pre-algebra students, we are going to get into section 3.2. It's building upon our simplifying that we've talked about it a little bit in chapter 1 and chapter 2. We're going to specifically work on algebraic expressions or expressions that have variables in them. We're going to apply what we learned from 3.1 with the distributive property, and we're going to use that to simplify our algebraic expressions. Remember, simplify just means to write in the simplest term, meaning combine terms that are like terms, and we'll see how we use the distributive property to help simplify as well. Our key terms, okay, first off, a term is each part of an expression separated by a plus or a minus sign. Like terms are terms that contain the exact same variables with the exact same exponents. Some new terms that we're going to look at here: coefficient. It's the numerical part of a variable term. And a constant is a term without a variable, meaning it's just a number. And the reason it's called a constant is because it doesn't change. A variable term can change depending on what number you plug in for the variable. All right, let's look at an example where we kind of apply our terms to a specific example. So first off, if we look here, each term, meaning the 5x, the 8, the 3x, the negative 5, the 2y, and the x. That means there are 1, 2, 3, 4, 5, 6 terms to start in this algebraic expression. You'll see as we get going, we'll combine them and there won't be as many terms, but each term is separated by a plus or a minus sign. Now, getting into like terms contain the exact same variables with the exact same exponents. We won't really focus on the exponent part right now. That'll come later in pre-algebra, but we're looking for terms that have the exact same variable. So if I look, this positive 5x, and they don't write it there, we just assume that it's a positive 5x or understand it to be a positive 5x. This term here is a positive 3x. And even though there's no coefficient written, it's understood to be a 1. There's a positive 1x. So if I combine these like terms into one common term with x as the variable, it would be 5x plus 3x plus 1x, which would give me 9x. I also have this term 2y. There are no other terms like it, so that would simply be just 2y. And then I have these these number terms that don't have a variable associated with it. So these are the constants. If I combine 8 and negative 5, I end up with positive 3. So this is the simplified form of this algebraic expression. 9 is the coefficient for the x, and 2 is the coefficient for the y term. 3 is just a constant because there's no variable with it. All right, I'd like you to take some time here, pause the video, and I want you to try to simplify these three expressions, right? And remember, simplest form is when an expression has no like terms and no parentheses. So to simplify, we'll use the distributive property if necessary, right? That's when there's parentheses, and we distribute that outside number to all the terms inside. And then we combine like terms, okay? These examples don't have the distributive property. It's just simply combining like terms together. So take a minute, pause the video, and see if you can simplify these expressions, meaning there should only be one of each term when you're done. All right, let's see how you did here. So in the first one, I had two like terms, the 8x and the 5x. And when I combine them, I get 13x, right? So 13 is my coefficient. There's no constant term. This is just a single term expression because there's only one term after simplifying. In number 2, I had like terms 6n and negative 2n. When I combine them, I get 4n, right? So 4 is my coefficient. And then I also have this positive 3. I just write as plus 3, and that's my constant term. So in this expression, there are two terms, the 4n and the positive 3. Now, that's standard form. Standard form is when you write it with your variable term first and then any constant term that you had. However, it's not incorrect if you were to have that written as 3 plus 4n. Both of those are acceptable answers. Now, in number 3, you can see that we had like terms of 3x and negative 8x. Make sure that the sign in front goes with it. So when I combine here, I have negative 5x, and then my constant terms were negative 5 and positive 6, which would leave me with a positive 1. Again, that's standard form, but you could have written that as 1 minus 5x, or you could have even had 1 plus negative 5x. All three of those are saying the same thing. Now let's look at some examples where we have to use the distributive property to help us simplify. We want to start by distributing through the parentheses. So in number 4 here, I'm just going to write that m there, and then I have this positive 3 times the parenthesis. So the first thing I'm going to do is I'm going to do positive 3 times n, and then positive 3 times 4m. So that would be plus 12m. Now, again, to get it in simplest form, I have to have one of each term. If you notice, I have an m and a 12m, right? And remember, if there's not a coefficient, it's understood to be a 1. So I'm going to take that 1 plus 12 and get 13m. And then I have this positive 3n. Now, with two variable terms there, it doesn't matter the order. Typically, it's written in alphabetical order, so I would put the m term first and then the n. But it's not wrong to have 3n plus 13m. All right, take a minute, and I want you to try number 5. Notice there's two distributive properties that you'll have to do there. And then if you want to move on to 6, and notice an error here, this should be a 7. Try those examples. So pause the video, and I will work through them with you in a minute. All right, number 5. Let's start here, and we got to be very careful with our signs. So this is a positive 8, and I'm going to multiply that by the x first. So that would give me 8x. And then I'm going to take this positive 8 and multiply it by the negative 4. So that would give me a negative 32. Now out here I have this positive 3 that I'm going to distribute. I forgot to draw my arrow there. I have a positive 3 times x, which would give me positive 3x. And then I have this positive 3 times negative 3, which would give me negative 9. So combining the like terms, now that the parentheses are gone, I'm going to take the 8 and the 3, right, 8x and 3x, combine them to give me 11x. Then I have negative 32 and a negative 9, which would give me negative 41. Right, again, standard form, my variables first. I could have written that as negative 41 plus 11x, right? But let's try to get used to writing it in standard form with the variable term first. Now, this one's tricky. The parenthesis set is in the middle. So what I'm going to do is the 5m, I'm just going to leave that out in front. And notice I have this negative 2 is what I'm going to distribute. So I'm going to distribute the negative 2 times m and get negative 2m. And then I have negative 2 times positive 7, which is negative 14. And then this is not in the parentheses. It's just in addition to the problem there, I have a minus 1. So my like terms are 5m and minus 2m or negative 2m. Combine those, I get 3m. And I have negative 14 and negative 1, which would give me negative 15. Now, this one's tricky because it doesn't look like there's a number out in front, right? Remember, if there's not a number, it's really just an understood 1, right? Or we're distributing that negative to all the terms inside the parenthesis. So first off, the x just stays. Now I'm going to distribute the negative, right? And negatives are like opposite of, right? So I'm going to take that and multiply. That would be a negative 2x. And then negative 1 times negative 3 is positive 3. So my like terms, right? Again, I'm going to write the 1 there just so I know. It's a 1x and a negative 2x. So if I combine negative 1x and positive 3, right? Because if I look here, I have 1, and then it's plus negative 2, right? 1x plus negative 2x. So I subtract those values, and since the 2 is bigger, it gives me the negative as my result. Now, if you were to look at an answer key, the 1 wouldn't be written there. It would just say negative x plus 3. This isn't wrong, but just know that these two expressions are the same thing. You don't need to write a 1 as a coefficient in front of a variable. You can, but if you're checking it on an answer key, it will not be written there. All right, last objective is to continue to work with translating verbal phrases into expressions. Okay, so we want to write a simplified algebraic expression to represent the given situations. Okay, remember, algebraic means there's going to be a variable involved, and simplified means in the end we only have one of each term, right? A variable term and a number term or a constant. So it says you have some cards and your brother has 15 more than you, right? So you have some cards. We don't know what that number is, so we're going to give it a variable, okay? And we'll just call it C, okay? And your brother has 15 more than you. All right. So since we don't know what you have, right, we're going to write that as your cards plus 15. Okay. So I have your cards, and then your brother has your cards plus 15. So if I were to simplify this, my like terms are 1C and 1C. That would give me 2C plus 15. That is the simplified form of that. Now, where this chapter is going to go is we're going to look at more specific examples. It'll say, well, how many cards are involved if you have 10 cards, right? Well, if I have 10 cards and my brother has 15 more, he has 10 plus 15, right? So 10 and 10 would give me 20. Plus 15 would give me 35. So we'll look at specific examples, but for right now, we're just looking at setting up an expression to model the situation, right? See if you can take that example and apply it to the last example there. All right, so let's see how you did here. It says you have some money in your wallet and your dad has 10 times more. Okay, so again, the variable that you use to represent doesn't matter. I'm going to use M because I'll just use it for money, right? So we don't know how much money you have, right? So we'll just define that as M. This is the amount of money you have. Plus, your dad has 10 times that amount, right? So he has 10 times the amount of money that you have, right? And so we want it simplified, meaning we only want one term of each, right? So we have 1M and 10M. That would give us 11M, right? So if we're talking about how much money you guys have, if you had $20, right, total you guys would have $220, right? Because your dad has 10 times that amount, so he'd have 200, you'd have 20, that'd be 220. But for right now, we're just looking at the expression in simplified form. All right, here is your practice problems starting on page 105. Okay, so on a separate sheet of paper, I'd like you to work on the following problems. All right, if you have questions along the way, make sure you email and ask. I hope everyone has a great day, and we'll talk to you soon.